So today I'm going to talk to you about how you can combine security and agile development at the same time. So first of all, I'm Michael Brunton-Spall. You can get me on Twitter on @Brunton-Spall and tweet me questions or talk to me throughout the things. My pronouns are he, his, and him. And I'm the lead security architect within the Government Digital Service, which is a part of the Cabinet Office in the UK government. So my job is to basically go around the rest of government and give advice on how to build systems that are secure, but to do it in a modern, interesting, and unique way. I'm told the second most terrifying thing that you can hear somebody say is, "I'm from the government and I'm here to help." Nobody likes to have the government come in and talk to them. However, the most terrifying thing you can ever hear in an organization is, "I'm from security and I'm here to help." And sadly, I'm both of those. So I'm probably the most terrifying person anybody can see in government, which is always worrying, because I'm always here to help. I like to help, but I'm both from the government and I'm from security. And my hypothesis and my theory is that agile development can make us more secure, not less secure. In order to tell you about that and so forth, what I kind of need to do is explain how security works now in organizations like governments, like banks, like finance organizations that are heavily regulated, and show you why it works the way it does. Because many of us have been sold a myth of security. Many of us have been told that it works in a certain way, and that's not actually what happens. So what is the current state of security? Well, actually, security tends to be summed up by a couple of different kinds of words. The sorts of things that people talk about is certification, accreditation. If you aren't doing certification and accreditation, you've probably heard of PCI. Has everybody heard of PCI? So that's the payment cards industry certification. If you take credit card information, you have to demonstrate that your system is secure enough to maintain that information in order to keep paying it. ISO 27001, which is an accreditation you can get as an organization to show that you take security seriously and you understand it. And I've never really met somebody who's a developer or works in software industry who likes PCI or ISO 27001. Does anyone here want to put their hand up and say they like ISO 27001? No, nobody likes it. It's not fun. It's not actually very valuable either. The processes you have to go through, the things you have to prove, are often at odds with how you actually work. So you spend a lot of time documenting how you do these processes that you don't really do. They're written down so everyone can say that you do those processes. But the reality is that people do different things in the background. And what those push us towards is this concept that security is a gatekeeper. Security's job is to prevent you from doing work. Security's job is to prevent you from making a mistake, to prevent you from accidentally breaking anything. So we end up with development teams that look like this. You come up with an idea, but before you can actually do anything with that idea, you have to go to the security team and get a risk analysis done. And they will look at the idea and decide whether it's too risky for your organization. Is it within the appetite of risk for your organization? Once they've said, yes, that's okay, it's not too risky, you can go to the design phase. You can design your system, you can design your IT system, but then you'll get a security team who will also simultaneously go along adding some extra features, and they'll do a design review, and they'll stop you moving into the next phase until they've done their design review. You can then code and build the system, and then you'll get a code review. So the security team will go through and check that you haven't used functions that you aren't supposed to use, that your code is secure by design, that it does all the right things. Finally, you can put it into the test environment, and you can do your functional testing. Does the system work? Does it do what you intended it to do? And in the meantime, the security team are going to go off and get penetration testing done. They're going to get people who are going to check your system is actually secure. And then finally, you're going to put it in production and everyone will be happy. And what you'll do in a traditional organization is you'll throw it over the wall to the operations team, and they will enforce something called a change control board on you. Everybody loves a change control board. I kind of feel like I should apologize for ITIL, because the UK government is actually who came up with ITIL and published it, and I'm really sorry. This is the ITIL process map for approving a change into production. So the first thing you have to do is you have to go and ensure that you understand the impact of the change. You have to find out what kind of change it is and categorize it. Is it a minor change, a major change, etc. You push the change to the Change Control Advisory Board, who will detect whether the change is appropriate to go. You then need to check when the change can be scheduled to be deployed into production. Finally, having scheduled the change to be deployed into production, you'll hand it to an operations team who might at some point actually do the change in production, and then they do an impact analysis to understand whether the change took effect, what it did, and tell you that your code didn't quite work the way you thought it did. This kind of heavyweight process is a way that we ensure security in many organizations. You can't change the system in production because you might change a security property of the system and therefore break the system. So somebody has to analyze it. You've got a security representative on your change control board checking every change and saying, have you changed the security of the system? Do I need to update the documentation? Do I need to do all of that? But the thing is, the IT industry has changed. The last 10 years has seen a massive shift in the way that we develop software. Agile development changes absolutely everything about the way that we do this. And one of the key things about Agile is that lots of people say they're doing Agile. I go to teams all the time who tell me they're doing Scrum, we're doing Agile. I met a team the other day who literally said, we're doing Agile, we're doing 2-week iterations. We've just finished our 6th design iteration, and in 2 weeks' time, we're going to start our coding iteration, and we'll do 20 of those coding iterations before we do our test iterations. So I always like to, just in case, I'm sure you all understand Agile, but I like to make sure that we all are on the same page. What is Agile? Because Agile with a capital A and Agile with a little a are very different. There are lots of different highly paid consultants who will tell you what Agile is, what their brand of Agile is, and sell you on their expensive training course. But Agile really comes back to these things. This is the Agile Manifesto. When the original originators of the Agile movement got together, they had a variety of different ways of doing Agile. And they all got together and said, what are the commonalities that we have? And it's this bit in the middle that's really key. It's about saying individuals and interactions and working software, customer collaboration, responding to change. And that is what people remember about Agile. When I go speak to people who work in the Ministry of Defense, who work in the Army, who work in the Air Force, so I go talk to people in intelligence agencies, they say, this Agile can't possibly work because you only care about responding to change. You have no process, no documentation. But actually, what the Agile Manifesto said was, while the things on the right have value, we value the things on the left more. They have more value than the ones on the right. It doesn't mean those things on the right have no value. So we value individuals and interactions over process and tools. There are tools and there are processes, and they are important. They matter. They actually help us deliver software, but not if they prevent individuals from interacting with each other, not if they prevent you from actually going and talking to your operations team or talking to the person who's going to use your software. If the process gets in the way of the interaction, it's not a good process. But a process that ensures that we can do it repeatably, that's a good process on the vision. It encourages and informs individual interactions. Working software is more important than comprehensive documentation. We should do documentation. Documentation is important. It helps that if I am run over by a bus, my co-workers can continue the work that I was doing. And documentation helps them do that. But if I have a 200-page manual on the system, but no working system, that manual isn't very useful either. So working software is more important than the documentation. You have to do both, but you have to have working software. Responding to change over following a plan. I have never seen a Gantt chart that was still true a day after it was written up. Whenever I've worked on projects and you look at, is this project going to be delivered? Those charts are lies. They are entirely fiction. They represent when everybody is desperately hoping that software will go into production. But they're never true. They're never, ever true. I turn up to boards and project boards, and they show me this wonderful chart and say, this is how it works. And I go, that's awesome. I'm going to go talk to the developers. I talk to developers, and they're like, yeah, we've been saying for about a month that we're not going to hit those milestones, but the management have determined that milestone was announced publicly, so we can't miss it. So, we're not going to miss the milestone. It's just not going to be the day that they said it was going to be. Which is a fairly common thing. We hit the milestone, we just didn't quite hit it in the same way. Responding to change is really important because it turns out we can't predict the future. I've tried over and over and over again, and I cannot predict the future. I cannot actually tell you how long it'll take me to implement a function. I can give you a good estimate and give you a good guess, but there's an error margin in there. And when we're building software, all those error margins add up quite a long way. And the people I talk to, they might say, I really want that blue, and I'll implement it, and it'll be blue. And then I'll show it to them, and they'll be like, no, the other blue. And you go back again. Responding to change is incredibly important. It's much more important than following some plan that was written 6 months ago. And finally, customer collaboration over contract negotiation. It is vitally important that you are not implementing what is written in a fixed document, but you're talking to the customer to what they want. Because quite often, they don't understand what they want until they see it. They don't understand how it works until they see it. And the person who interviewed them and wrote it down had a view of the world. They wrote it down, and then you read what they wrote down. Now it's as if you're talking in 3 different languages. The chances that you got down exactly what was intended is very unlikely. So you need to be able to collaborate with people. Contracts, planning, documentation, processes and tools, they're all important. They're all incredibly important. They help us build software repeatably. They help us have confidence in the software we build. But more important is collaboration, change, deliverables, and people. So for me, Agile means building software together, having a team that is built around how we're going to build the software, that includes everybody. One of the teams that I work with has 3 developers, 1 operations person, 2 lawyers, 1 procurement consultant, and a project manager, all sat together on the same set of desks. The conversations that you hear from that team are fascinating, because it turns out developers and lawyers are actually quite similar. They speak a foreign language to normal human beings, and they're sticklers for details and pedants to a fault. The team also particularly likes tea, so they often have tea, and they all go out and they'll get tea together and they'll have teacups and so forth. When those software developers are trying to implement some part of the software, and they're like, oh, is this going to break the law? Are we asking the right question? They can actually turn to the lawyer sat on the desk next to them and ask the question directly. And when the lawyers aren't charging you for every 3 minutes of their time, it turns out they're quite happy to respond and to answer. And we make their lives easier, which means they like us. Teams that work together, that build software together, are much more effective. And that's about support and trust. That team needs to know each other, be able to support one another, and trust each other. And it means that management has to trust that the team is going to do the right thing, that they can set the goals and the vision, set the direction, but leave the team to own the delivery version of that. The other thing that Agile really gives us is a push towards building simple systems. Simplicity is a key to Agile. It is, to me, Agile is the art of maximizing the work that we didn't do. If I build a requirements document that I know a team 2 years down the line are going to have to implement, I'm going to put in every requirement that might have to come up, because I don't know, and I'm not going to be able to revisit it or change it later. So I maximize the amount of stuff that could go into the system. And then everybody who reads it is going to go, oh, well, I didn't know quite how that requirement meant, so I'm going to implement every possible option, which means I end up with massively complex software. And that software doesn't work as well as it can. But Agile is about maximizing how much work you don't do. It's about looking at it and saying, what are we not going to do today? We're going to focus on this bit and deliver this bit, and we'll worry about the rest another time. As Dan says, your code is not an asset. Everybody thinks of code as an asset. It's a value to the organization. It's not, it's a liability. The more code you have, the harder it is to change. The more you have to maintain it, the more difficulty you have in a variety of different ways of dealing with it. Your code is a liability, so you should minimize how much code you actually have. You should minimize the amount that you're producing. Again, as Dan also says, Agile is about minimizing the lead time for delivering business value. The faster I can do what the business wants, do what the organization is there to do, the better the organization can be. And it doesn't matter whether your organization's job is to sell widgets, is to trade stocks on a stock exchange, or to deliver benefits to citizens across the country. Delivering the value is what you are there to do. Software developers aren't employed to write code. That is an important thing you need to understand in Agile. Software developers' job is not to write code. Their job is to build a system that does what the business needs it to do. And code is just the way that we do it. But code in and of itself has no value. It's not important. So what does that mean? How does that actually manifest itself today? Agile's changed over the last 10 years a little bit. Minimum viable product or service. That's the MVP, the term that people use. One of the nice things about this term is that you as a development team get to pick what minimum means, but your customers get to decide whether it's viable or not. You never really get to decide whether that's going to work. So you have to build the smallest thing that you think serves the needs of all of your customers. And then you're going to iterate on it. You're going to change it. You're going to put it in front of real people, have them use it, watch them use it, and then you're going to change it so that it gets better. And you're going to keep doing that over and over until it's the best it could possibly be in the smallest amount of time, the smallest amount of deliverables. To do that, you have to release early. You have to release often. You have to be able to put it in front of people and change it and put it in front of people. And that's incredibly important in Agile. How do I get that to happen? I have to build processes and tools that help me do that. They're still important. The UK government formalised this. This is our development methodology. We start with user needs. Government exists entirely to serve the needs of the citizens. The reason that government exists is to collect taxes so that we can pay for healthcare, so that we can pay for all of the functions of government. It exists to provide benefits to people who are trapped in the worst ends of life. It exists to ensure that you can visit a loved one who is in prison. It exists to ensure that you know other people who are in other cars on the road are legally allowed to do so because they're qualified. They know how to use that car and they're not going to kill you. It exists to ensure that beef that is in the animal market doesn't get ground down and fed to other cows because that's unhealthy. It exists to ensure that the land that you own stays yours and nobody can steal it. Government is there to deliver those user needs. So we start with that. And when we talk about a digital service, we start by saying, we're going to do a discovery. That's a short period of work where we say, what are those needs? And is a digital service the best way of meeting them? Or is there something else we could do? How should we best meet those needs, and how do we ensure that we can build something that meets those needs? We then build it up and we build an alpha. That is normally paper prototypes or a little, very simple, flat HTML prototype, something that we can put in front of a very small number of users. We're talking 10, 50, 100 people at maximum throughout an 8-week period, where you can put something in front of them and say, does this work for you? I can go out and see a farmer with a laptop and say, if you needed to claim money back from the EU, how would you do it? Is this process going to work? And they'll look at it and say, I need like 7 different documents to fill this in, and one's here and one's at my accountant's office. This is really hard. And we can revisit how that process works, because while it's a simple thing that's drawn on paper or a HTML mock-up, it's incredibly easy to change. Once we've got an idea that we have a service that actually works, we start going into a beta process, and we're building bigger and bigger services. We're allowing more and more people. We start connecting the back ends and the data, and we start having to deal with users' data and hold it. Once we have done that, we are continuing to change that service the entire way through, and eventually we put it into production live in front of users, but we don't stop changing it. We don't stop reevaluating, am I meeting every user's need? Are they being able to use this system? And we keep changing it continuously in live. Government is predicated on building projects that have a start date and an end date. But we changed that. We turned to government and said, you build services, and services don't end. If you need to end a service, it's because you are actually deliberately choosing to withdraw the service. And that's a different thing. But services should continue to change. Tax still needs to be collected every year. But the way that you do that changes. The way that people interact with you change. Their needs might change. The way they interact with accountants might change. And you need to be able to change that continuously. When you throw it over a wall to an operations team and say, not my problem anymore, it becomes a terrible system for people to use. And we don't want to be there. So if we're working with a team that works like that, I have an Agile team, I have a small team of developers, or a large team of developers. I have a team of over 100 developers in one of the projects. I need to say, how are they going to build a system that is secure? Because security is the team that says, no, it has to review everything that's happening. But my security team can't review every change going into a production system every time they happen if we're doing this Agile thing. Like, my security team gets quite upset when I say this, because then they start saying, but where's the specification that I can check it against? How do I understand the security properties? So what we did in the government is we got together some of the smartest security people that we could find. We started looking at some of these systems, and we came up with sets of principles. We said the best way that we can build security into these services is to have principles that anybody can follow. They're not designed to be used and read and understood by security professionals, because those people are, like me, they're very special. They need to be read by normal people. They need to be read by normal developers. They need to be read by testers. They need to be read by anybody who's working in those teams. So we come up with about 3 different documents at the moment for those principles. The first is protecting personal data. People want to trust government, mostly. It would be nice if you trusted government, but people do trust government to hold their personal data. The government probably knows how much money you earned last year. It knows where you live. It knows what kinds of car you have. It has all kinds of information about you. And it is vitally important that you trust government to hold that data securely, sensibly, and safely. So we produced a set of principles on how to protect personal data in bulk, because lots of companies do it fairly well, but we're seeing breaches happening all the time. So we need to make sure that we're building on good principles. And these principles, the URL is here, and I'll put the slides up later, but the principles cover essentially know what data you are storing and make sure it's the right data and it's proportional, understand who has access, and understand how it's kept. If you follow principles along those 3 lines, you will generally build a system that protects the personal data appropriately. So we can give people principles that say, do things this kind of way, think about these principles, and then they can apply them per service. We also think there's a set of principles for securely building services. So we produced some security design principles, and these are divided into 4 categories. The first one is before you start. What do you have to think about in advance before you build a system at all? Make sure you cover a couple of those principles. Make your services hard to compromise. We can cover all the things that we do that make it hard for somebody to actually compromise a service. But services get compromised. So if we assume breached, if we assume that a service will be compromised, we can also apply some principles that say, how do I reduce the impact of compromise? How do I make it hard for somebody who has compromised my system to have continual effect on the system? And then finally, the other critical thing that people forget is, how do I know if my system has been compromised? So what principles can you design into your system that make it easy to detect the compromise? And these principles, the security design principles, I think we came up with 22 or so, are principles that help you understand that. So you should do network segmentation. That means that it's hard to move around, move laterally within your service. You should have trust boundaries in those segmentations so that services on the back end don't just trust that everything on the front end is good and happy and healthy. You should have auditing that links off elsewhere. Those are the kinds of principles that we put in there to say, if you build a system, this is how you should build it. And finally, the one I'm going to cover the most of is the principles of risk management. So ISO 27001 is a risk management tool. It is unwieldy and unreadable unless you're an information security specialist. To be honest, it's pretty unreadable even if you are an information security specialist. It's not a lot of fun, so we tried to boil it down to the simplest possible things that we could in a modern world, in a world that's designed this way. And we came up with 8 main principles that you should understand. The first one is accept uncertainty. It is very easy for people who deal with risk, every system has risk, to assume that they understand all the risks and that they can manage every risk. But you can't ever reduce the risk to zero. You can't ever deal with it. You have to accept a certain amount of risk. And more importantly, there is risks that you won't understand, that you won't know. It is not possible to know every possible thing that could go wrong. So you have to start on the premise that I'm not going to be able to do that, so I need to be able to go as far as I can, but no further. That's a really important part. The second thing is that security has to be part of the team. Security cannot be external to your system design, your system implementation, and your general system. It has to be part of the team that builds it, because security cannot be bolted on later. You cannot just sprinkle some magic crypto dust over the top of your system and go, ta-da, it all works. I've got public-private key encryption or HTTPS, and it all's fine. That's not how security works. It has to be embedded in the design of the entire system. It has to be thought through everywhere. You need to understand the risks, and everyone needs to understand the risks. In order to know whether you're doing the right thing or not doing the right thing, you have to know what risks you're taking. You have to be able to trust the decision-making in the team. The team, if they get to make the decisions about what things to implement, what to do, when to do it, as an organization, you have to be able to trust that they're trying to make the right decisions. Everybody is trying to do the right thing. So trust that decision-making and make sure it's there. Security is part of everything. It is not the special, it's not just firewalls. Security is how you design the business process. Security is how you ensure people interact with the system. And this ties into the 6th principle, which is one of the ones that, to me, is the nearest and dearest to my heart. User experience has to be outstanding. Security merely has to be good enough. If you build a system where the system is secure, but to use it properly is too hard, people will circumvent your security systems, and it'll be a worse system. The security of a general system is much worse. If I build a system where I have to change the password every single day, the chances that I'm going to write that password somewhere insecure that someone else can get it becomes very, very high, and the entire security system is compromised because I've made it too difficult to operate. So the security has to be good, but the user experience of using the system must mean that people choose to use it in the secure manner. It has to be as easy to use in a secure way as possible. If I trust the team to make decisions, I need to be able to audit the decisions. Not to blame them, but so we can go back and say, why did we make that decision, and can we make sure we don't make that decision that way in the future? Or when did that change? How did that change? Why did that happen? We believe in trust but verify. So make sure that you trust people to make appropriate decisions, but verify those decisions are the right ones. Find out who made them, how they were made, what the decision-making process is, so you can go back and reflect on how that works. And finally, if you're building a system and you're worrying about risk, you need to understand the big picture impact. Again, it's very easy for developers to say, I'm going to install Vault or KMS or use something to manage my keys, and it's a very small siloed thought about doing key management. But actually, your system as a wide system is a much bigger thing, and you need to understand the impact of every decision you make on the bigger picture. A good example we have is there might be situations when you interact with someone else in an interesting way. So the UK government provides you with information about your benefits, and one of the pages you can go to says, how much money did you get from your benefit last week? So you can go and check, did I get paid the right amount? But many banks ask, if you have a security check with your bank, and I phone up my bank and say, I'm so-and-so and so forth, one of the questions they'll commonly say is, how much money were you paid in your last paycheck? If my system can reveal easily how much money anybody got paid, I've just broken the bank security system. And so we need to work out how we do that. We round the numbers appropriately to beyond what the banks care about. And we talk to the banks and make sure they understand that. So understanding the big picture impact is vitally important. So how does Agile help if I'm doing security in that way? I am going to take a breath at some point, I promise. How does Agile make this better? How do I build secure systems within Agile? Well, the first thing is, if Agile is continual delivery of business value, if I'm constantly changing how much value I'm delivering, I'm constantly, continually delivering in the system, then I'm also continually accepting the risk. And I'm changing my risk profile on a regular basis. So how do we do that in Agile? Well, the first thing is, security needs to stop being the department that says no and needs to view itself as an enabler. The security team inside your organization, their job should be to enable everybody else to do things well and in a secure manner. And as soon as they get their mindset, the things they focus on change dramatically. I'm going to move slightly sideways for a quick point. There is a difference between safety engineering and security engineering, and very rarely do the two meet. In security engineering, you assume a malicious user. You assume a system that is working perfectly, but somebody is malicious. Somebody is coming in and trying to hack your system. An insider is trying to get data out. Something bad is going on because of a bad actor. In safety engineering, you consider everybody to be a good actor, but you assume bits of the system are going to fail, and you try to work out how they fail in interesting ways. Very rarely do those two processes of thought combine together to allow you to say, what happens if a malicious actor is using a system where something has failed? Or what happens if one of the people inside your safety critical system turns out to be malicious and deliberately turns off the fail-safe? How does your system work? Combining the two together is really important, and the two predicates I always have is security. You think about malicious users. 100% of your users are evil, and that you need to work out how to deal with the fact that you still need to deliver business value in that situation. In safety engineering, you need to remember the important predicate: 50% of your users are below average and are likely to make mistakes. If 50% of users are below average, how is that going to work with your system? And bringing that principle over to security matters as well. How easy is your system to use securely if 50% of your users are below average and don't really want to do the appropriate things, instead of assuming that everyone is a great-minded, happy, nice person? So, back to Agile. The unit of delivery is the team. That's what Agile tells us. The team delivers itself. The unit of decision-making is the team. And in security, when we think about risk, we have to think about every decision has a risk impact. So how do we do that? In a normal organization, the security team will go off and do a risk impact assessment. They will look at what the security risks are, and the delivery team never see that in many cases. I have worked in organizations, or I've worked with teams where there is a document that describes every possible risk that's in the system, and that document is classified, and none of the people building the system are allowed to read it. Which makes it quite hard to build the system, because you don't know what could go wrong, because the document that tells you what could go wrong, you can't read. And then you have security people going, but I wrote all this down, why is the system still crap? And it's like, well, because you classified it. It's like, why did you do that? So the first thing is educate the team to the threats. In government, that can be quite hard, because some of the threat intelligence that we have is classified information. And that means I need to get people's security clearances, I need to ensure they can come and be briefed appropriately, I need to tell them how they can share that information. But a lot of the time, that information isn't terribly classified. If I'm building a system, chances are any reasonable person can think through what the threats are if they just took 5 minutes to do so. So helping the team understand those threats and documenting them. One of the benefit systems I work with has a concept of anti-users. So we generally have, user profiles. Who is going to use the system? This is going to be used by this kind of person and this kind of person, this kind of person. Well, we have bad users. Who is going to try and break the system? Well, we know that independent hackers might. We know that journalists might be interested in this. We know that state-sponsored actors might be interested in this. Criminal gangs, fraudsters. By building up those pictures and having those as posters hung in the development team's room, all of the development team were aware at all times, who are the people who might be bad actors on this system and what might they do to the thing I'm building? Educating the team to the threats helps them understand what they're building, the context in which they're building their code, and means that they can build better things. You can keep a running risk log. We're experimenting with different kinds of wikis or Confluence or issue trackers that track risk. So you say, here are the 20 risks in my system. And at any given time, anybody in the team can look at it and can see what are the risks. And every story has risk decisions applied to it. So every time I play a story, it says either it counters one of these risks, or it adds a risk to a risk log, or it does something in there. And that means that when we sit down and somebody says, we should have a password reset screen, and somebody can say, oh, that adds a bit of risk to people doing stealing people's accounts. That's a valuable thing to know, because then you can start making a decision on a per-story basis about what risks you're willing to accept and what you're not. You can apply controls per story. You can say, actually, we're going to require two-factor authentication if we're going to turn that feature on, because we need to put that in there as well. And you can start building security controls in on a per-story basis. And that's not perfect, because security is holistic. So that will work in the small, but actually the security of the whole system is going to change. But much like developers are used to the concept of technical debt, which is where you make decisions now that you know you're going to have to go back and undo later because it's quicker, faster, better, delivers better value, we build up security debt in the system. We know what decisions we took and what risks we are taking. We can look at that risk log at any time. The governance board can look at the risk log every week and say, how is our risk position right now? And then they can say, whoa, we know we need business value, but actually we're now running too high a risk. We need to focus on some of that and remove some of that debt and pay off some of that debt. And it's more expensive to pay off later, and we can apply all of the standard debt rules that we have. The other thing is that simple systems are more secure. If I build an Agile system and it only does 10% of the functionality of the intended full-end system, it only has 10% of the surface area. So we're building a more secure system, one where we understand the methods and all that stuff. And that means my development team can continue building, day in, day out, understanding the risks, understanding the security. Even though they're not security experts, they can understand the impact of what they're doing. They can understand how the system works. And again, security has to be the easiest option for them. Doing things in the secure manner must be the easiest option. When I decide I want to use a base image in my virtual machine, right now the easiest option is to probably just go pick the default Ubuntu image. But what if my security team create base images that are already locked down and have all the packages we don't care about removed so that it's a much smaller, much safer image? If that image is there available for me by default, all my teams will use it. What if all of our accounts have 2FA enabled by default in AWS consoles so that we know that if I get given an account, it won't be compromised? It's easy to create a new account in there. I can still do it in an agile manner, but security are making sure that the options available to me are the easy options available to me are the secure ones. And that's where security needs to change the way it thinks and start saying, how do I make that easier? How do I make it so that you can run penetration tests inside your acceptance testing process? And that's how I talk to developers. But it turns out systems aren't just developed. They're actually run and operated as well. And that's changed in the last 10 years quite a lot as well. DevOps has come along. And DevOps is a terrible term that means a different thing to every single one of you, and probably a different thing to me as well. But there's a couple of common themes that we get from that. The first is infrastructure as code. So those of you who've used Puppet or Chef or Ansible, or you're using CloudFormation, or you're using any of the modern services for building and orchestrating your system, you have your infrastructure defined in code. So this is what ours looks like for GovUK, for the front page of the UK government's website. We publish all of this publicly. Anybody can look at how we configure our systems. Anybody can look at how we set up our system. So this example is Varnish, I believe. Yes, this is the Varnish config. So it says when I say Varnish should be installed, here's where the template file should be, here's how it should be configured, and it gets me a set of a configured Varnish. So I can say, put Varnish on this box, and it will just do that. And there's code that defines how that works. That means that we have shared infrastructure. It's really easy to see how it works. More importantly, that's not just infrastructure as code, it's infrastructure as testable code, which means that I have a set of tests that do things like this. This one is for Nginx, but it's a set of tests that confirm that our configuration for Nginx, if you add aliases, does the correct thing in terms of creating vhosts in the right place with the correct names based on the domain name that you expect, which means common misconfigurations that we would have done before will be caught if our code is incorrect. So we can run a set of tests on our code continuously to say, have we misconfigured any servers? Have we done something that is inappropriate? Do we know that we have disabled HTTP on port 80 on all of our internal servers so that they only talk over 443? Because that's what we care about. We want them to be there. So we have tests that assert that we haven't accidentally configured port 80. Because if we did that, that would be a real issue. The other thing we can do with those tests is we can run automated tests. This is a set of tests. This is a set of smoke tests that we run. These are written in a BDD-style tool, I think in Cucumber. And what they do is when we go to do a deploy, we deploy to an internal cluster of machines, and then we run some tests where we go and try and fetch a number of the standard pages. And that confirms to us that all of the infrastructure is working as expected. The requests go through, they get served by the back end, they come back, and everything works. And that's amazingly powerful for us because it lets us know that we haven't misconfigured things. It lets us know that everything works the way we expect. We haven't broken things, which means that we can change things quite easily, which means that we can deal with patches. So when OpenSSL has a vulnerability, some of the organizations I work with in government, a year later, have still not patched it because the rollout of the patch process is so complicated that they can't do it. It can take 3 months or 6 months to get it into the release cycle, to get it into the change control board and deployed into production. But when we do that, we've got infrastructure as code. So we can say, what machines are affected? Well, how do I know what machines are affected by a patch in Nginx? Let's say there's a security vulnerability in Nginx. I have this bit of configuration. This is a puppet again, that says this is how I configure Nginx. And the critical thing here is that at the top, you can pass in a version. So by default, we just say it's present. And when you say pass in a version, it will ensure that version is installed. So I can then do something like grep over the code base. What versions are currently configured in my code base? And we use something called Hira, which configures the puppet and says for these different hierarchies of machines, this is what version is installed. So you can see that our precise machines, by default, were running 144, but we've actually updated almost everything else to be 146, so that they're slightly newer. The front-end machines are running 146. That's configured across all of the front-end machines, but the back-ends have been held back a patch version for some reason. Within this command took me 2 seconds to run, and I don't work on the operations team for the web for GovUK. But I can look at this and immediately say, I know what machines we have that are vulnerable. If I know there's a security release for 145, I have a clear indication about what is vulnerable right here, right now. That information took me a few seconds to find. If your organization isn't doing this, how long do you think it would take you to find out how many machines you have and which ones are running version 145? Because I'm going to guess it's longer than a few seconds. You might have to go consult the documentation, but what are the chances the documentation is actually accurate and matches what's in production? This code is redeployed to production every 10 minutes or so. So the worst case I have here is that this might be wrong, but if it's wrong, it's only wrong by 10 minutes. That's a pretty good understanding about what's going on in my service. What about when I want to update it? Well, actually, all I have to do is check into the test environment YAML file, a new version, 147, commit it, get it pushed, and suddenly all of my test machines will upgrade themselves to 147. And I'll be able to run tests and check whether that patch works or not in the entire test environment. And that's awesome. What happens if I find that some of the machines it doesn't work for? Let's say the back-end and front-end machines, the back-end machines, there's some reason 147 breaks the way that we have it configured. That patch is urgent to me. I want to get it out to the front-end machines now. We'll do some development and testing, and we'll roll it out to back-end machines in a couple of days. Well, I can do that as well. I can change it so that I only change the test front-end versions to 147 instead. So I can specify which machines get it. Once that's done, I can repeat it in production trivially by just doing the commit and rolling out. The ability to patch machines at that speed, to be able to understand what's going on in my infrastructure, is critically important to understanding that I have a secure system. So what does that lot combined give me? If I'm doing Agile development, and I'm doing this DevOpsy thing, which is Agile operations, and I'm doing them together, I'm getting automated testing. I know that the application does what it was supposed to do. I know that it does it every time. I have continual validation that I didn't just break something from before by changing it. And I can also put security testing in there. It is possible to automate the low level of pen testing tools, or to put in things that say, I'm going to check that you have a CSRF token that is appropriately set. I can put checks in to make sure that I don't break fundamental security properties that I care about. We have a service I worked with where we had checks that when you added a bank account to an account, that it wasn't a bank account that was flagged as a malicious bank account. We have some information from banking services that we can call an API and say, is this a known fraudulent bank account? I can check that that configuration is still present every time and that nobody has accidentally broken that, which means I know that security property is true of my system. That automated testing is amazingly valuable for me as a security property, as well as for reliability and integrity property of understanding whether the system is still doing what it's supposed to do and whether it still delivers on the user needs. I get infrastructure as code. I've talked about this already, but you get the ability to actually look at documentation. That code is the documentation for the system. And we go and talk to security experts and security people who are responsible for the systems in production. You start talking about infrastructure as code, and they're like, oh, God, anybody can change anything at any time. You show them that you can audit that code, and they go, you've just saved me 6 months of work. I can actually focus on other things. They suddenly get why it's valuable. To be able to see your infrastructure written as code, to be able to apply tools on top of that to find out information. What changed when? When did we release that patch? How often do we patch our services? For the last 10 major patches for Heartbleed, for OpenSSL, for Logstash, for whatever it is, all those things, how long did it take me to actually patch it? I can go look at the commit messages and check. Was that patch within a day, within 7 days? Have I met the SLAs that the security team requested of me? Suddenly you get a massive amount of auditability that doesn't exist in all of those Word documents that are stored in repositories that nobody ever reads again. I get fast, repeatable deploys. And fast, repeatable deploys means I can do it more often. It means that I understand that it will be the same every time. I understand that it'll be reliable. And that makes it very easy at 3 a.m. to be able to apply a security patch. When I went to go work with one of the departments, they deployed twice a year. That was their formal policy. Once every 6 months, they did a deployment. That's not entirely true. They deployed 6 times a year because they did a deployment. They always scheduled a second deployment 2 weeks later to fix the bugs that they had caught before the deploy but didn't have time to fix, and a fix 2 weeks after that to fix the ones they caught after the first deploy. So they did 6 deploys a year. When we spoke to them, we discovered the deployment instructions had changed every single time they'd done a deploy. There was not one instance where they did a deploy where the instructions weren't wrong, and they would fix the instructions, and then by 6 months had gone by, the system had changed enough that the deployment instructions were no longer accurate every time. When we went in and we said we want to do this regular deployment thing, and they freaked a little bit, and we overruled them, which is quite nice. Sometimes in government I get to go in and just hit people with the stick of power. We overruled them, and we built a system that we deployed to 10 times a day. And they were absolutely freaking out that we were deploying 10 times a day. After a week, we pointed out that our operations engineer had now done 50 deploys. And there was not a single person in their organization that had ever done 50 deploys of their existing systems. When something goes wrong at 2 a.m., which of the 2 engineers are you going to trust to be able to deploy the security patch in a hurry? The one who's done 50 deploys or the one who's done 4 in his lifetime? That's not a great place to be. So those repeatable deploys matter hugely. It also matters that we can automate those. We get audit logs. I know who changed what and when. I have a Git history that tells me exactly who decided to turn off the firewall rule that allowed something in. I know exactly why the firewall rules changed. They're often the comment on that commit. I can link back to a work story and understand why that change happened and whether it was appropriate. So when we do have an incident, and everybody has incidents, we can do some really good traceback to say, why did we make the decision and did we not see the knock-on impact? And how can we change our documentation, our process to make that better? We get code review of infrastructure changes. We have a 2-man rule. Nobody can commit into the production repository by themselves. They have to create a branch and issue a pull request, and a second person has to review it before committing it. That means that every single change to every one of our production servers has been seen by 2 people. That's vitally critical, and that gives me confidence that the system works. So why does that matter? Last couple of slides, I promise. The Australian Intelligence Agency, the Australian Signals Directorate, produced a document that's down here that said that 85% of cyber intrusions on government systems in Australia could have been prevented by doing 4 simple things. They said these 4 things could prevent the majority of the intrusions they see as a government organisation against persistent targeted attacks. The first is application whitelisting. Servers are only running the processes they need to run. Well, it turns out Puppet does that for me. It rechecks every time. Are the binaries still the same binary? Is the configuration still the same configuration? Is it running the processes I said it should be running? Is it running anything weird? It does that for me. Patching. They said, people not patching the operating system is one of the critical things that mean that that you can be attacked. But again, we patch our operating system really regularly because we do changes all the time. It's really easy. They said patching a second time because it's so important. They said patching your application, your OpenSSL libraries and so forth is really important. Again, my DevOps gives us that as well. And minimizing administrative controls. The Australian Intelligence Agency looked and said the majority of systems administrators are logged into their admin account and also browsing the web and reading email. And that means that they're very easy to be attacked via those mechanisms. None of our systems administrators log into the servers on a regular basis. We very rarely log in with an administrative account because we don't need to. We push code and then we tell an automated tool to do the deploy. So we very rarely have this problem as well. There are a whole new world of problems. That's a very simplistic wave. But done well, those agile techniques about development, about operations and so forth, mean that we have more secure software, better than we've ever had with the old style security says no system. And that's my hypothesis and my backing up as to how we do that. It is a requirement that I have to tell you that we are, of course, hiring because the government needs awesome people. Some of you may not be able to work for the UK government, but I do say government is in desperate need of people from the tech industry. Like, if we don't do something, we will be left with a legacy of terrible, terrible IT services that are maintaining the security and your personal data across the entire world, in every government, in every place. So if you can't work for us, work for your government, work for your local government, work for your local council, but please, we need smart tech people working in government to help make it better. These days, the UK government is doing Agile, doing DevOps, releasing multiple times per day. We are using Docker in production. We've overtaken many startups in London now with the speed at which we're doing things. That's a great place for us to be able to say the government can do this stuff and you can do it in this environment. It's no longer a stuffy place with bowler hats and canes and so forth. As you can tell, I'm a civil servant. So that's me. At Brunton-Spall, please feel free to contact me, and if we have any time for questions, we can do questions. Thank you.
So, whoops.
I can take a breath now, right?
Yeah. Okay, one very easy question. Do you work with James Bond?
I'm probably not allowed to tell you.
Okay. A nice question regarding the talk we had before. How do you treat third-party open source libraries?
Yes, the same way everybody else does. We're spending a lot of time looking at the supply chain at the moment. I absolutely echo that the supply chain in software is a fundamental vulnerability to modern organizations, and it's something that needs to be looked at, needs to be addressed. There's a huge number of startups, people working in that area who are trying to make it easier to understand what impact that has on you and where it will change, but it's got to get better. It's going to get better over time. We're trying our best, as well as everyone else, to work out how on earth we deal with the Node.js dependency chain. Like, the fact that somebody can have a library for padding characters on the left and break more or less the entire internet is insane. Like, from a security perspective, if they changed that library to do something horrible, who would have known that they were now running that in production? It's a world that terrifies me completely. The best we can do is look for people like I Am the Cavalry and say, how do we get this better?
Okay. What is the best way to maintain the risk log over time?
I don't have a best way. I don't believe in best ways because everybody's company is different. I hate wikis. It's where information goes to die. But actually, the continual updating and the continual ability to see it works really well. I know some other organizations are using issue trackers and just munging it a little bit to keep the risk log. The critical thing is anyone should be able to see it, and it should be very easy to connect it with your story tracking tool. Even if that requires a person manually updating it, that would be sufficient. But index cards on a wall will also work quite well.
Okay, last question. Can you imagine diversified governmental solutions at regional or municipal levels in order to mitigate risk and increase robustness?
Let me think about that question for a second. Federated systems are really hard to secure. It's a really hard problem. The problem you have is around trust boundaries. So who trusts who in for what things and so forth. There are a variety of good federated systems. We know ones that work. We know ones that don't. Government has to do a certain level of federation and delegation of authority to different organizations and so forth. So it's an ongoing challenge. I like to believe it's possible. You can't ever reduce the risk to zero, and all we ever do is move the risk around. So I don't know quite what it would look like, but it can't be worse than it is today, right? That's the thing I keep telling myself. It can't get worse.
Okay, thank you very much.
Cheers. Thank you very much.